So our next speaker is Spencer Logan. Spencer grew up in Colorado, learning to ski at Hidden Valley, for all of you who know where that is. He began avalanche forecasting at the Bear River Avalanche Information Center in northern Utah in 1999. He studied snow at Montana State University, started working at the CAIC in 2004, which means that he has the longest tenure of any current staff member. He's the Science and Operations Officer at the CAIC, which means that he's involved in avalanche forecasting as well as research. His research includes avalanche accidents, patterns in avalanche problems, survival rates of avalanche victims, and many other topics. So please welcome Spencer Logan.
Thanks, Ethan. We're going to take a big change in topics, and I'm presenting some of our ongoing research addressing this question. And like most simple questions in the snow and avalanche world, there's actually a lot more nuance that we have to understand in the question and the answer. So the CAIC produces a lot of different kinds of forecasts. And evaluating a weather forecast at a study plot is going to require different methodology than evaluating a single avalanche path. And our forecasts there, or our backcountry forecasts, where we're talking about patterns of avalanche activity across large areas, or often dealing with the absence of information. And for our backcountry products, we're evaluating an avalanche danger scale that has multiple combinations of avalanche size and distribution at the different danger levels. So today I'm talking about evaluating our public backcountry avalanche forecasts, the products that the majority of our users interact with. And then we have to think about what we mean by good. Fortunately, lots of work, because what's good for our partners in CDOT may not be good for somebody who's riding all day across multiple drainages around a mountain range. Fortunately, there's been lots of work done in the meteorological realm of verification, and a really important paper back in 1993, Murphy described several measures of goodness. So one is how well the product that's issued matches what the forecaster is thinking. And this is something that we do constantly at the CAIC. Every day we're checking to make sure that what we're putting out really reflects what we're thinking about. Then there's the benefit of the forecast to the user. And we're doing things like Snowpool, and Ava's going to talk about some of the projects we're doing to look at how our users are actually benefiting and interacting with the forecast. And then there's the quality, which is the degree to which the forecast corresponds to actual occurrence. So today I'm talking about the quality of our public backcountry avalanche forecasts. So our simple question becomes something a little bit more like this. But we have to understand what the conditions are that day. And we're doing that through a process that we've come to call assessments. So this is a hindsight review of what went on. So then we can look at our hindsight review and what was issued and see the differences there. So our forecast process is done in a consensus manner. We bring a group of staff together, we figure out what's going on, we just figure out together what we're going to do, and then we turn it around to the public. Because we're forecasting for 24 and 48 hours in advance, once we build a picture of what the current conditions are, we have to figure out what the weather's going to do to them. So our backcountry forecasts are very reliant on the weather and figuring out what's going to change. And we issue danger ratings for 3 elevation bands. We take the highest of those danger ratings and call that our Tier 1 information, and that's what's displayed on our homepage map. And today I'm going to be focusing on those Tier 1 ratings. Our assessment process is done by individual forecasters, so we're removing that consensus process. They're done in hindsight, so practically that's summer or early fall, but that means that instead of relying on a weather forecast, we have the observed weather actuals. And the hindsight process takes in all available data. So if we're assessing February 21st and it was a really stormy day, and we get avalanches reported later that week that we know occurred on the 21st, When we go back on the assessment, we can see those avalanches. But we use the same forecast guidance. So we've changed some of the parameters, but the underlying model that we're using for both our forecasts and our assessments is the same. We published a paper last year at ISSW, so if you're interested in the nuts and bolts of that, there's a lot more in that paper. We run the assessments over consecutive periods, so practically that's a month or two. And we select these periods because they're interesting. We don't learn a lot when we're looking at really easy forecast periods. So we're looking for periods with big changes, big avalanche cycles, interesting storms, because that gives us a lot more information about our process than if we just look at a really boring day. When we started this assessment process years ago, we were forecasting for 10 different avalanche zones. A couple of years ago, we moved to a flexible zones. So we have spatial elements that we can aggregate based on light conditions. To allow us to compare through time, we're doing our assessments based around a point. So we're asking our assessors to determine the avalanche danger around an area. And this allows us to compare Honeycrisp and Pink Lady, rather than trying to compare Granny Smith and grapefruits. So the assessments that I'm showing you today, almost 1,200 assessment days, over 4 winters. So our last 2 winters of the 10 zones, and our first 2 winters of the flexible zones. We usually present this information in correlation matrices, but I've squashed those down to single columns, where we're looking at forecast agreement, and then over-forecasting and under-forecasting. So an over-forecast is where the issued danger is greater than the assessed danger. So we issued a moderate danger, and going back for that same day, our assessor looked at the data and felt like a low danger was more appropriate. Conversely, an under forecast is where the assessed danger is greater than the issued danger. So maybe we issued a moderate danger, and going back, looking at the evidence, our assessor determined that a considerable danger would be a better fit. So here's our scoring for all 4 of those winters. Looks okay. When we pull it apart, it gets a little more interesting. So we see a little bit of difference between our 10 zone and our flexible forecasts. And if we pull those for 2 years of the flexible forecasts apart, we see a change there. So it looks like we're seeing improving agreement as we use the flexible forecasts. Those are really cool numbers, but they're not statistically significant. So statistically, these are not different distributions. In fact, all 4 of those winters, all 4 of our assessment periods show the same distributions. So even though the absolute numbers look a little bit different, this is our summary score that's applicable for all of them. Over all 4 of those periods, we see a very similar ratio of over to under forecasting. So our errors are pretty consistent. From a public safety perspective, we think that an over forecast error is more acceptable than under forecasting. It's better to send somebody out prepared for dangerous conditions and have them find something a little more benign than it is to tell them that it's hunky-dory and they go out and encounter big avalanche cycles. So how do we compare? This is a whole bunch of financial advisors and their agreement between their predictions and actual market changes. And while I wouldn't trust any of the CAIC staff with your money, our forecasting looks pretty good in comparison. Here is National Weather Service snow forecasts aggregated over the western US over a similar time period. And at the 24-hour point, they are getting about 92% agreement with their forecasts. So the CAIC is not as good as the Weather Service yet. A little more relevant, a few years ago, Frank Teckel at the SLF looked at their forecast agreement and came up with about an 85% rate. When Frank looked at surrounding European forecast centers, the Canadian Avalanche Center, and the CAIC, we were all converging about the same agreement rate, even though methodologies are really different. So 76 and 85 look like big differences in absolute numbers, but from a statistical perspective, they're probably not that different. But it would be nice to have a bigger number. So everybody wants the bigger score, so why aren't I showing you a big number? I think this is one of the keys. We're doing our assessments in challenging periods. So for example, last January was one of our assessment periods. Over that month, we had about 13% of our days with a low danger, and about 13% of our days with a high danger. So that's a huge change in the course of a month. This is the Tier 1 danger for one of our assessment points. So starting in early January over there, you can see kind of a low period. Not much was going on. Storms came in, and we had a really active period in mid-January. Lots of avalanche warnings and special products out. The black dots are our assessments for that same period. In this case, we had 3 sets of assessments. And I have not color-coded the assessors. So assessor C is not always the 3rd dot on there. But you can see some pretty good agreement during our period of high danger. Maybe a couple days where an assessor thought we could have dropped the danger a little bit. And then a different pattern as we see the avalanche danger taper off. So the assessments indicate that maybe we could have dropped the danger a little bit earlier. But also notice that there's a difference in the assessments. So one of the things that we can do with this process is look for biases among the staff and figure out why somebody may be indicating a lower danger or always going with a higher danger. And one of the things that we're doing with this are the critical factors. So with each assessment, the assessor has to pick a bucket of information that was most important for them when they were looking at that assessment. And by far and away, snowpack structure and number of avalanches are our critical factors. So it could be lack of avalanche activity indicating a lower danger, or lots and lots of avalanches indicating a high danger. And structurally, it could be the presence of a persistent weak layer, because this is Colorado, or it could be a big storm changing that overall structure. And this is important because it means your observations matter. Providing information to the CAIC about what you're seeing, whether it's lots of avalanches or no avalanches, what you're feeling in the snowpack and as far as layering is really, really valuable. This stuff is very important to our forecasters, and it really helps us produce a better product. So going back to our motivating question, this is how I'm going to answer it today on stage. So 76% of the time, we're getting it right. Which is not bad, considering that we're often working with very sparse or absent data, and we're talking about a single danger rating for very large spatial areas. Which is why practically we don't rely on the Tier 1 data. We provide danger ratings at 3 elevation bands, and we provide lots of supporting information as far as avalanche problem types and descriptions of where you're going to find them where you're going to find those issues in the landscape. We're not relying on a single variable. So while this analysis is mine and any mistakes are mine, this is a huge project, and it's required weeks and weeks and weeks of sweat and headache from the rest of the staff. Up top is the reference to our ISSW paper. If you're interested in the nuts and bolts of the assessment process, or more of what we can tease out of this, I'll suggest you start there. And I do think we have time for questions.